Number 64. Analysis of the gases in a sealed reaction vessel containing NH3, N2, and H2 at equilibrium at 400 degrees Celsius established that the concentration of N2 to be 1.2 molarity and the concentration of H2 to be 0.24 molarity. And then they give us this balanced equation. So we have N2 gas plus 3 H2 gas, which comes to equilibrium with 2 NH3 gas, and they give us a Kc. Beautiful. But the question's asking for calculate the equilibrium molar concentration of NH3. Okie dokie. So first thing is, I'm just going to write this a little bigger because we just need to work from it. So I do see that we have coefficients already in front. So that means that this is basically a balanced equation. You could always pause the video just to get some practice seeing how, an equation is balanced. But this equation is balanced and we're good. The next thing I'm going to write down is what they gave me. Well, they told me that I had a concentration of N2 to be 1.2 molarity. So I have N2 being 1.2 molarity. And the concentration of H2 was 0.24 molarity. So that's this guy. So 0.24 molarity. Now, I just want to point out a common mistake here. Some students may be tempted that since there's a 3 in front of here, we would times this number by 3. But they're saying that this was the total concentration. If you times this by 3, you change the total concentration. So whatever numbers they give you, just write them down, all right? Don't change them. Now the question's asking for what's that equilibrium molar concentration of NH3? Well, molar concentration, remember, concentration is just a fancy word for saying molarity, so capital M, and molar is molarity. They just dropped the I-L-Y, right? Molar, I-T-Y at the end of this word. It's all leading towards molarity. So we basically just want to know what that molarity is for NH3. Well, they said that all of these were at equilibrium. So that's beautiful because if we have equilibrium values, we can use our Kc expression. Remember, the Kc expression is this, right? It's this general formula of products divided by reactants. So maybe what I'll do is I'll just maybe bring this up here. So let's write our specific Kc equation for this reaction, right? And just remember, all aqueous and gases are allowed. No solids or liquids, so always check those states. But here they gave me a gas, a gas, a gas, so we are good. So let's see. The Kc is products over reactants, products divided by reactants. So it looks like we got NH3, right? NH3, raise that now. You got to raise it to the coefficients. There was a 2 in front of the NH3, so I have to raise it to the second. Divided by the concentration of N2. There was no number in front of the N2, right? There was no number here. So remember, that just means that you have one of them. So you can raise it to the first, but you don't have to. And remember, the reactants, if you have multiple reactants, they're being multiplied by each other, not added as it is in the balanced equation. So I'm just going to string along the next bracket. We got H2. Close that bracket up. And here I see a coefficient. There's a 3 here. So I have to put a 3 here. Now, we have the specific equation. Let's plug in our numbers. In this case, we're solving for this. We don't know what this is. So maybe I'll put this is the x value. What else do we got? Well, we know that N2 was 1.2 and the H2 is 0.24 and they gave me the Kc value. So I know this. So I know everything else, right? The Kc is 0.5. I know everything else except for the NH3. So let's just plug in the numbers and solve. 0.50 equals, it's going to be x squared, right? And then divided by the 1.2 times the 0.24. And that's cubed, right? So let's see, if I can try to bypass, one step, this is basically cross multiplication, right? So I can basically do 0.5 times 1.2 times 0.4 raised to the third. You could also, get this to be one number and then do your cross multiplication. Just for the sake of having, limited amount of space, I'm just going to do this first. So we're going to be left with x squared equals, let's figure that out. So 0.24 cubed times 1.2, and then times it by 0.5 because we're cross multiplying. So I get 0.008294. Try not to round until the end, okay? We still want to solve for x. So remember, the opposite of being squared is the square root. So we have to square root both sides. And that way you get rid of this little square thing. And now you have x equals, and remember, x was the concentration of NH3, right? So let's see, whatever that square root is, and then we're done. I'm just going to square the number. And let's see. Looks like I need 2 sig figs. Every number is, has 2 sig figs. Do we really care? No, but, just to have it there. 0.091. The units for molarity is capital M. So you are done. And that's it. They wanted the molarity of NH3. You got it, 0.91. So NH3 would be 0.91 molarity at equilibrium. And there you go. Hope for this helped. Thank you so much for viewing the video. Subscribe to the channel and let me know in the comments if this helped you out. And if it didn't, let me know too. Any, constructive criticism is welcome here. So thank you so much. I hope you guys are having a great day and let's keep studying hard. See you later. Bye-bye.